The Blue Origin's rocket just exploded on the launchpad during what was supposed to be a standard hot fire test of its upcoming New Glenn rocket. A hot fire test is essentially the ultimate stress test. It's designed to simulate the exact brutal forces the vehicle will experience during an actual launch into the orbits. While the mainstream media is calling it a testing anomaly, in simple words, it exploded. But the underlying reality is a nightmare scenario for both Blue Origin and Amazon. This was supposed to be a prep for launching 48 Amazon Project Kuiper broadband satellites as early as 4th of June. Now that's delayed indefinitely. So what actually happened? What is Blue Origin trying to fix behind the closed doors? Now you might be thinking, hey, it's a test. Isn't the whole point of a test to find flaws before they actually launch? Well, ordinarily yes. But the Blue Origin is trapped in a brutal race against time. If you think this is just a minor setback for a billionaire's hobby, think again. Because this is where the story shifts from an engineering problem to a multi-billion-dollar corporate crisis. This single blast has triggered total panic over at Amazon and directly threatening Amazon's multi-billion-dollar Project Kuiper satellite constellation. And most importantly, its deployment timeline. The project is planned to network thousands of low Earth orbit LEO satellites designed to beam high speed internet across the globe, a direct competitor to the Elon Musk Starlink. Now, to maintain their FCC license, Amazon is under a strict legally binding federal mandate. They must launch at least half of their entire planned satellite constellation into the orbits by a rapidly approaching regulatory deadline. If they miss that window, they risk losing their operational license entirely, flushing billions of dollars down the drain. And guess who they paid to launch a massive chunk of those satellites? The Blue Origin's New Glenn. So Amazon is legally running out of time to get those satellites into the orbits, and they were banking everything on this success, but it exploded. Now if you have noticed, the Blue Origin uses a highly specific term here. They called it an anomaly. It's an official statement. We experienced an anomaly during a routine hardware test. No personnel were injured, and we are currently assessing the root cause. In aerospace terms, an anomaly is basically a polite word for something broke unexpectedly. It might have involved something, but according to the witnesses and the launchpad tracking reports, the event wasn't just a small glitch. In fact, in rocket science, a hardware anomaly on a full upper stage test is a massive and extremely expensive problem, and it resulted in a highly visible hardware explosion. Hot fire tests are high risk by nature. You are dealing with the cryogenic fuels, the supercooled liquid methane. Rockets are basically controlled explosions, but even a small leak and sensor glitch can cascade fast. The Blue Origin's B4 engines are relatively new for flight, though they have been tested before. Previous New Glenn flights had some engine issues too. Now, thankfully, because this was just a ground test, the entire launch pad was entirely cleared of any person, so no one was hurt. But the physical hardware, now that's a completely different story. Blue Origin is now aggressively sorting through the debris to figure out exactly what component gave that way of pressure. The New Glenn relies on the Blue Origin's proprietary BE4 engines, and unlike old school rockets that burn highly refined kerosene, the BE4 runs on a cutting edge mixture of liquid oxygen and liquid methane. Liquid rocket engines are masterpieces of fluid dynamics and thermodynamics. They required mixing fluids kept at hundreds of degrees below zero, pumping them at extreme pressures and burning them at temperature hot enough to melt steel. To achieve precision control and reusability, modern launch systems utilize variable thrust liquid rocket engines. This allows the rocket to throttle its power up and down dynamically, depending on the atmospheric pressure and the flight parameters. But that versatility introduces a mind-boggling complexity. Everything comes down to a component called the mixing head or injector. Think of it as a hyper-advanced shower head that sprays the fuel and oxidizer into the combustion chamber. If the fuel and the oxygen don't mix at the exact microscopic ratio, or if there is even a microsecond of delay, you encounter what engineers call a combustion instability. If the pressure fluctuation inside that chamber is spiked by even 5 or 8%, it can trigger an automatic safety shutdown, or worse, a violent physical shock wave that tears the plumbing apart. And if a valve leaks or injector plate wraps under the heat, the flame can travel backward into the fuel lines. That is called a flashback, and it turns a controlled engine into a multi-million-dollar bomb in a fraction of seconds. So if it's that risky, why use methane? Well, recent aerospace engineering studies highlight that liquid methane is highly prized because it burns exceptionally clean and doesn't leave a thick soot inside the plumbing, and can theoretically be manufactured on Mars for future deep space travels. But dealing with methane is like double-edged sword. It requires advanced engineering called a staged combustion cycle. They have fuel inlets routing cryogenic liquid straight towards the high pressure turbo pumps, and they are the mechanical beasts. They feed on thrust chamber at mind-boggling speeds to keep the metal wall of chamber from literally melting under thousands of degrees of heat. Engineers use a technique called film cooling, flowing a thin layer of unburned fuel along the inside walls of the engine nozzle to insulate the underlying metal alloys. If that cooling film drops by even a tiny fraction, or if the turbo pump valve hesitates even for a millisecond, you get an instantaneous local hotspot. The extreme thermal shock causes the structural fatigue and the wall ruptures, and the massive internal pressure turns the entire engine assembly inside out. That is what engineers mean when a hot fire test turns into an uncontained structural anomaly. We will update as more data comes out. This is one of the biggest explosions in recent years compared by some major historical incidents. But the real drama isn't just happening in the Blue Origin's testing labs. It's happening inside the executive boardrooms at Amazon. This explosion means New Glenn could face a multi month grounding or a review process by the FAA. Every week, New Glenn sits grounded on a test pad. Amazon crawls closer to missing its critical regulatory window, threatening billions of dollars in sunk infrastructure costs. Building rockets is extremely hard, and as the old aerospace saying goes, you either find your engineering flaws on the test stand or you watch them fail live on the launch day. Jeff Bezos' team found this flaw on the test stand, but the clock is ticking loudly and the margin for error has officially hit zero for them. This brings us to the ultimate clash of tech titans, Jeff Bezos versus Elon Musk. For years, many critics have pointed out the stark cultural differences between these two aerospace giants. SpaceX famously uses an iterative development model. They build prototype fast, fly them early, blow them on camera, and gather data and build a better on the next week. They treat explosions as a normal part of learning, whereas Blue Origin prefer to develop in near total secrecy, testing meticulously for years behind the closed doors and trying to ensure that when a rocket is finally rolls out, it's perfect. But this latest anomaly proves no matter what, how slow or cautious you are, rocket science doesn't care about it. An anomaly like this won't kill the Blue Origin. They have the financial backing of one of the richest person on earth. But it shattered the illusion that their slow and careful approach would guarantee a flawless rollout. It's a stark reminder that space exploration is relentless and brutal, where every single component has to perform perfectly under impossible conditions. What do you think? Is Blue Origin going to recover from this in time to save Amazon's satellite constellation? Or SpaceX has already won the commercial space race? Let me know your thoughts in the comments below, and I will see you in the next video.